So today in class we talked about car depreciation, and for the purposes of these notes I'm going to go ahead and use a Toyota Prius. And I'm going to use a 2012 model. And I looked it up on the internet, and these run about 19 grand. Obviously you can have it be more or less depending on what fun things you get, but around 19 grand. We also assume today that we lose 15% of the value of the car each year. Now in class we saw two different ways to calculate this. I could take 19 grand and multiply it by 0.15, in which case I would get $2,850. And then I could take my 19 grand and subtract the amount that I'm taking off, the amount I'm losing, that 15%. And I would come up with a new price of $16,150. This would be my price after 1 year. In class today we saw that there was a faster way to do this. You could take 19 grand and multiply by 0.85. And if you do this, you get the same amount, $16,150, but you get it with one step. The reason being is here we have 15%, and we're taking that 15% off, whereas in this situation we're keeping 85% of our cost. Now, to find out how much my car would be worth after 2 years, I could just keep multiplying by 0.85 each time, and I would have, let's see, 16,150 times 0.85. The next year, after year 2, my car would be worth $13,727.50. And I could just keep multiplying by 0.85 over and over again, and that would give me how much my car is worth each year. Now, in class we also saw, well in some of the classes at least, that you could write an equation by this. Because we're taking the original amount of the car, and after every year we're multiplying by 0.85, so here would be for 1 year, and then we multiply by 0.85 again, there would be for 2 years, multiply by 0.85 again, there would be for 3 years. Since we're multiplying by the same number each time, we could really think of this as an exponent. For instance, this would be 19,000 times 0.85 to the third power, and this would tell me how much my car would be worth after 3 years, which would be $11,668.38. Okay, this would be year 3. Well, that leads us to a more general equation. We could say y equals the original amount of my car times 0.85 to the x power, where y is the value of the car in dollars, and x is the number of years that have passed. Okay. If I take a look at this equation in my calculator, so I go into my y equals, I plug in 19,000 times 0.85, and I raise that to the x power, and then I look at my xy table. Sure enough, year 0 is 19,000, year 1 is 16,150. Oops, I think I dropped a 0 there. And so we can tell how much our car is worth. In class we talked about how long it would take for us to get to $5,000. And in some of the classes we got a little farther than others. One really nice way to do this, if I want to know how long it's going to take for my car to be worth 5 grand, is to graph it in my y equals. So I'm going to plug in 5 grand. And then I'm going to look at my table and see when it gets close to 5 grand. So it looks like it happens somewhere for me between years 8 and 9. I'm going to change my window then to go from year 0 to, let's maybe say year 12. I'll go a little farther than I need to. Here I'm going to go from $0 all the way up. Well, I know I have to go at least to 5 grand. I might as well go all the way up to 1,900 since that's how much my car is worth initially. If I look at a graph now, you'll see one curve. This curve represents the worth of my car after each year. And you'll see a straight line at 5,000. And if I want to see where those two things intersect, I hit second trace. I go down to intersect. First curve, enter, enter, enter. And I see my car is worth $5,000 at year 8.214. Okay, so I just wanted to show you guys how to do this with your graphing calculator to save you a little bit of time.